Welcome everyone, I'm John Romero, co-founder of id Software, and I'd like to thank Atera for allowing me to speak to you. I'm going to talk about the programming principles of id Software, and I believe they may relate to how you work in your IT and DevOps jobs. I'm going to take you on a journey back to the beginning of id Software. Are you ready to be entertained? I do realize that some of what I'm about to say may sound insane, but we were in our 20s when we started id Software, and we didn't know there were any limits. So I grew up in a wonderful small town in Northern California named Rockland, population 6,000. In the 70s, I was massively addicted to spending loads of time in dark arcades and playing all the games there and getting really good at them. In 1979, before anyone had a computer at home, including me, I went to the local college when I was 11. And started learning BASIC from the college students. I just went up to them and I asked them what the words in their listings meant, and I wrote it all down and experimented with those words on the HP 9000 mainframe there. Well, to keep me at home, my parents got an Apple II Plus. I was done going outside. I spent all my time programming on that computer. A few years and 20 Apple II games later, and I finally learned 6502 assembly language, the language all fast arcade games were written in. Then I could really make 80s games like these. Well, not quite arcade games, but home computer games, which were on the Apple II. Let's just say that the Apple II was my personal home arcade, as well as a million other Apple owners. When I was a sophomore in high school, I did some programming for the Air Force when I was 15 years old. We lived in England then, and my stepfather worked for the Air Force. In order to get into the high school coding class, I showed the teacher I could program in 6502 assembly language, and I ended up at the aggressor squadron the next day. I was literally coding in a vault. Because I was a kid, they gave me false data to use with my code. I can't tell you what I was programming, that's classified. It's an odd but true story. Well, after high school, I kept making games, and by 1987, I was working at Origin Systems. My first job was porting 2400 AD from the Apple II to the Commodore 64. And by this time, I had made 74 games in 3 previous startup game companies. Capital Ideas Software, Inside Out Software, where I ported Might and Magic 2 to the Commodore 64, and Ideas from the Deep, and I was 21 years old. Well, I went to work at a company named SoftDisk at the start of 1989. I learned how to program a DOS PC there, and I made a small game or utility per month for about a year. Then, I created a game product called Gamer's Edge at SoftDisk, and I had to hire a team of game developers. Well, I hired John Carmack and Adrian Carmack, they're not related, into my department for programming and art. Tom Hall came in at night to help us out since he was already at SoftDisk, and he loved making games. This was the first time that any of us had worked with another person on a game after making them alone for about 10 years each. It was incredible. While creating our first game together, Slordax, John Carmack discovered the smooth scrolling trick on the PC. Tom Hall and John stayed up until 5 a.m. making a demo called Dangerous Dave in copyright infringement. The next day I saw the disc on my desk, I ran the demo, and I watched the screen scroll smoothly pixel by pixel. It was a massive eureka moment for me. It was like a bolt of lightning. And I'll elaborate on that in a moment. id Software was born that instant on September 20th of 1990. One thing led to another, and we spent a week putting together a demo of Super Mario 3 for Nintendo, which they liked but decided not to publish because they decided to only publish their games on their NES platform, which was a smart move. Well, it was no problem. We decided to use the tech for a different game, the Commander Keen Trilogy. Well, why would a side-scroller be a huge hit on PCs in 1990? Well, because no games on the PC could scroll horizontally smoothly per pixel. The PC had been out since August of 1981, but in 9 years, no one had figured out how to make the screen scroll smoothly per pixel until the Dangerous Dave and copyright infringement demo, which led to Commander Keen. The Commander Keen trilogy provided the start of the company, and we made these 3 games in 3 months, from September 20th to December 14th of 1990. It was a massive hit for us, and it was so popular that people cosplayed as Keen for years at events. The game pioneered the creation of game engines. We designed the game as an engine that operated on different data for different games. It was the only way to get that trilogy done so quickly. In fact, in 1991, when we were working on Keen 4, we started licensing the engine for the first time. It was the beginning of the modern engine licensing business. Development on our games went very smoothly and quickly because we stuck to some core principles that are important even today. Through this talk, I'll highlight some of our core principles. And I'd like to highlight something else right now, namely this photo. Has anyone seen this before? It's a picture of us at our lake house in Shreveport, Louisiana. The funny thing is that people have asked me for years what was in this picture. So I analyzed it recently, and here's what you see. So this is John and me in early September of 1990. We were working on the Super Mario 3 demo that we planned on sending to Nintendo. We both worked on this huge D&D table, Dungeons & Dragons, that John had. We used to play D&D on the weekends, and those sessions led to ideas for future games like Doom and Quake. So Tom Hall took this photo. We were working on the Super Mario 3 demo, and on top of the monitors is one of those old Intel reflective astronaut plushies from back then, from marketing. And to my left is my notepad, which was like a task list of bugs to fix. The computers that we had, we brought those in on the weekends. This is our high-level task list of what had to get done to finish the demo. And this is Tom Hall's area where he was doing all the graphics for the demo. He recorded gameplay on a VCR, and he played it back, pausing the action so he could duplicate the tiles exactly in Deluxe Paint 2. There was no Photoshop back then. The TV set had a 13-channel selector on it, and it was connected by an RF modulator. Very old school. Its software was formally founded on February 1st of 1991, and we made 12 games that year. Shadow Knights, Dangerous Dave and the Haunted Mansion, Rescue Rover Hover Tank 1, Rescue Rover 2, Keen Dreams, etc. We actually took 2 months per game, but we made 2 games simultaneously. And this was basically due to having 10 years of intense game development experience prior to this. But it was also due to our first principle. No prototypes. Just make the game. We had no time. Polish as you go. Do not depend on polish happening later. Always maintain constantly shippable code. This is how we made so many games so quickly. We had the entire game in our heads already. We just needed to quantify what needed to be done, and then we went about working on it until the game was finished. There was no prototype for our games. We just made them. But remember, we had a small team of 4 people, and we could do this. Obviously, large teams require way more planning. So time for a quick story. One day, it rained really hard, and Cross Lake in Louisiana rose, and it was flooding everywhere. And I needed to get to work. We were furiously working away on our games, and I had to get back to it. So I had just gotten showered and everything, and I drove down the street and basically saw this. The entire road was flooded. Well, I basically waded through the huge flood and water snakes and everything all the way to the house, and I took another shower and I got back to work. We were all so excited to be making our games 24/7, and also note that during this year of 1991, of 12 games, we moved id Software from Louisiana to Wisconsin. And that takes quite a bit of time out of our game development. But we couldn't afford to have anything go wrong while making these games at such a fast pace. And so we created another principle that helped us developing quickly. So it's incredibly important that your game always be run by your team. Bulletproof your engine by providing defaults. So, upon load failure. So if you had like 100 people trying to develop a game that will not run, you're paying for 100 people to all sit around and wait for the build to get fixed. So we recognize the importance of having the game always playable, and we decided to bulletproof our engine by making input solid. So basically, when you're trying to load bad or corrupted or data that's just not there, we would check for this and then provide a default piece of data that will kind of keep the game running and quickly show you what you're missing. So if you fail to load a sprite, you load a bagel, right? Theme song's not loading, play something obviously wrong for the game. Missing sound effect, same thing. Well, after 1991, id Software's first stage of company development was complete, and another important principle was in effect. Keep your code absolutely simple. Keep looking at your functions and figure out how you can simplify further. We wrote all our games all the way up to Quake in pure C, not C++. Okay, so stage 2 was about to begin. In August of 1991, we decided to move to Madison, Wisconsin. Tom Hall and I visited at that time, and we found it to be really nice. Tom used to live there while he was in college, and we just moved all 4 of us up there and continued working on our games. Only 4 months later, we're found dead in the snow, victims of Wisconsin's brutal winters that we did not research. Moral of the story, do your research. We knew how to program an assembly language, but not how to ask Tom Hall, hey, what are winters like up here? So after 6 months, we moved down to Texas. So here's a new principle. Great tools help make great games. Spend as much time on your tools as possible. I wrote a tile editor back in 1991 named Ted. Ted was used for 33 shipped retail games, several of which were 3D games like Hover Tank, Catacomb 3D, Wolfenstein 3D, Spear of Destiny, Rise of the Triad, Corridor 7, and others. So it's January 1992. We decided to go all 3D based on Catacomb 3D's promise. It looked cool, it just didn't play really cool. Wolfenstein 3D took 4 months of development time to get to its shareware launch with 1 episode of levels. It took 2 more months to finish all 6 episodes and the hint book. And the first month, it sold 4,000 copies, all priced at $60 each. Spear of Destiny took 2 months. It's a prequel to Wolfenstein 3D, and it was retail only. Soon after, Tom Hall traveled to Kentucky to work for a couple months on Wolfenstein VR. Yes, this was 1992 VR. Back in the days of Commander Keen, I had discovered a small 3-person game company called Raven Software in Madison, Wisconsin. I called them up. We went over and we introduced ourselves. Flash forward 7 months later, and we did a little work with them by modifying the Wolfenstein 3D engine and licensing it to them for a game called Shadowcaster. Shadowcaster's tech improvements were sloping floors, lighting, and fog, and this engine looked slightly better than Wolfenstein 3D, but it just wasn't good enough for our next game. So John Carmack spent some time, some months, thinking about how more advanced this new engine should be for a game that we decided to call Doom. Based on the rapid development of our previous games, we came up with another important principle. We're our own best testing team, and we should never allow anyone else to experience bugs or see the game crash. Don't waste other people's time. Test thoroughly before checking your code in. No throwing it over the fence for testers to find, put a bug in the database, and then fix it later. It's really a wasteful cycle. Well, after 1992, id Software's second stage of company development was complete, along with another principle. As soon as you see a bug, you fix it. Do not continue on. If you don't fix your bugs, your new code will be built on a buggy code base and ensure an unstable foundation. If you check in buggy code, someone else will be writing code based on your bad code, and you can just imagine how much waste that creates. Well, the ideas from Doom came from our D&D campaign, which was full of demons. We also loved the movies Evil Dead and Aliens. Doom's design was a mashup of ideas, and at the beginning of Doom's development, we created a new core principle. Use a development system that is superior to your target to develop your game. So before Doom, we're making games for DOS while developing on DOS computers. We knew that we could do better if we used more powerful computers and a more advanced operating system to develop our games. So we developed Doom on Next Step workstations. They were far superior to DOS. Next Step eventually turned into OS X, OS X. This also meant that one of our core principles was upheld. Great tools help make great games. We could make far better tools on Next Step. DoomEd and QuakeEd were two of the most important tools that we had. They both really helped us create great levels, and test them very quickly. You might not have known this, but we had 5 people on our team creating Doom. Well, after Tom Hall left, we hired Sandy Peterson and Dave Taylor, which brought us up to 6 people. And unbelievably, while making Doom, we had to stop all production and create the Super Nintendo port of Wolfenstein 3D as fast as possible. Because we were starting from never having programmed a Super Nintendo. It took us 3 weeks because we had to learn the hardware. Then we jumped back into making Doom again. Well, we uploaded the shareware version of Doom to the University of Wisconsin server on December 10th, 1993. The excitement for the game was unprecedented. People were creating files in the upload directory that were sentences like, "When will we see Doom?" We got random phone calls in the office asking when it would be out. Time for a quick story. During the final day of Doom's creation, we worked 30 hours. We had the game running on all the computers in the office to ensure that it was, really solid. However, on a couple computers, the game just froze. The menu could be brought up, but the gameplay just stopped. So John Carmack thought about what could possibly be happening, and he figured out the solution without doing any debugging. And he was correct in the solution, and we finally uploaded after a 5-minute fix and more testing. At the beginning of 1994, I started working with Raven Software and developed Heretic using the Doom engine. I wanted to see how an inventory system in a medieval version of Doom would play. It turned out pretty great. Anyone here remember Heretic? Well, we also made Doom 2 in 1994. Over 8 months, and it was released October 10th. In addition to this, we did the Jaguar Doom port ourselves. Again, we were multitasking and making multiple games. 2 games in 1993, 3 in 1994. In 1995, we started working on Quake. We had 9 developers, 4 designers, 3 coders, 2 artists, and I was the only one to do both coding and design. I wrote QuakeEd and experimented with level design in full 3D. Again, we started with a clean code base. No code from Doom was used in Quake, which was another of our core principles of development. Write your code for this game only, not for future game. You're going to be writing new code later because you'll be smarter. Also, you're not tying yourself down to the limitations of your past code. Invent new things. Quake's engine was being developed by John Carmack and rasterization by Michael Abrash. John Cash worked on the network code. He went on to become the lead programmer of World of Warcraft. So, time for a quick story. So this relates back to our belief that developing in a superior operating system can result in a better game. Well, while we were making Quake, we also made a deal with Cray supercomputers to buy a Cray 6400 super server for half price. Our plan was to have our development team connected to it and BSP and LiDAR maps, as well as crunch whatever new kinds of data that we could create with our next game's engine. So the computer room in Quake's DM3 level was going to be full of Cray computers as a reference to this new hardware that we're going to acquire. Unfortunately, Cray was bought by Silicon Graphics before Quake was done, and the deal fell apart. So the computer room in Quake is filled with the usual rectangular mainframes instead of C-shaped Crays. After publishing Heretic, I started working with Raven on Hexen. I wanted to see how an FPS would play with the hub level system and character classes. And Hexen launched on October 30th, 1995 during the Deathmatch 95 event that was happening at Microsoft in Redmond. A month later, I got Raven started on my next design, Hecatome. It would be the third game in the series, Heretic, Hexen, and Hecatome. Well, Hecatome was never finished. It was turned into Hexen 2, and it wasn't the same game design. And during this time, we also noticed a small game company making some nice games like Raptor, Call of the Shadows, and we brought them down from Illinois to basically make a game that we would publish. And they called themselves Rogue Entertainment, and about 14 months later, they released Strife, which used the Doom engine. It was an FPS RPG, it's a role-playing game. FPS is first-person shooter. And it was really fun. Back in 1996, it showed that combining genres could actually make a fun FPS. Nowadays we have Destiny and other FPS games, but Strife came first. Also during 1995, we made the Ultimate Doom, which was a retail version of the full Doom, but with an extra episode. And we also made master levels of Doom. So id Software was still 9 developers in size. We released 2 games in 1995 while working on Quake. And work continued on Quake, and 14 months after starting, we released Q-Test on February 24th, 1996, for the world to test our internet gameplay. And during the next 4 months, we worked very hard to complete Quake. We also released Final Doom, created by Team TNT and the Casali brothers, and Death Kings of the Dark Citadel, which was an additional set of levels for Hexen. One important principle that helped us get Quake done faster was this: encapsulate functionality to ensure design consistency. Examples of this in Quake would be the torches on the walls. Well, we could have made the level designers place a torch model, then a fire model, then animated, and then a torch sound entity all at the same location. But then, when we needed to move a whole bunch of stuff, something would have gotten left behind. So it's far easier to just create a torch entity that had all the functionality built into it. Also, water in the game needed to sound, basically you needed to hear that everywhere where water was at. So if the water got modified in the level, moving all the sound entities all over the place would have been a big mess. So it's far easier to just make the game play the water sound whenever water was being drawn on the screen. So this was a renderer level feature, and it was out of designers' hands. And it ensured consistency, and it saved memory. And we did the same thing for the sky audio in Quake. If you can see the sky, you can hear the sky. So I released Quake shareware on June 22nd at 5:30 in the afternoon Central Time on the University of Wisconsin at Madison's FTP site. Time for a quick story. So while Michael Abrash was programming the renderer for Quake, he was interleaving CPU instructions with FPU instructions, it's the floating point unit, to calculate perspective correct texture mapping. And sometimes, while he was playing the game, for one frame, the game would show a completely different part of the level. So he isolated the only instruction where that could happen, and he determined that it was impossible for it to be an invalid value. So he had a friend from Intel come over and go through his analysis, and his friend agreed with him and told him that there was a known error with the floating point divide instruction on the Pentium chip. It was a hardware error. So there was nothing that we could do about it, so we just left it alone. This bug is known as the Pentium FDiv bug. Quake is a game that introduced the world to mouse look, a high-speed true 3D world, and internet multiplayer. Clans sprung up immediately, as did esports and tournaments everywhere. Quake World launched 5 months later. Making games, it was and still is our life. Like, we love it more than anything else, as you can tell by our release of 28 games in 5.5 years by less than 10 people. Many other games were released that used our licensed technology over the years. And here are some core principles that we learned from all this work. Try to code transparently. Tell your lead and peers exactly how you're going to solve your current task, and get feedback and advice. Don't treat programming like each coder is a black box. The project could just go off the rails and cause delays. So programming is a creative art form based in logic. Every programmer is different and will code differently. Don't waste time focusing on a rigid coding style. It's the output that really matters. Now, I want to talk about AI. When we were creating our groundbreaking games from 1990 onward, we were doing things that no one else had done before. But there were some possible ways that AI could have helped us. It only requires us to imagine that a computer network from 33 years in the future was available, however. PCs back then had few resources, which greatly limits what can be done with generative AI. Like, there were no GPUs, TPUs, there was very little memory, like just megabytes. There was no internet, there was no AI frameworks, and there was no Linux. But let's pretend that we did have this magic AI resource back then. Which way could AI have helped us? Well, by the time we got to our third 3D game, Wolfenstein 3D in 1992, we were still a small team of 4 game developers. We didn't have QA or any automated processes for testing our game. Training an AI to play a 3D game like a normal player would have been a huge help testing all our levels for design errors. Today, this is called automated testing, and it's usually automatically run after a new build is generated before it's pushed to a distribution platform like Steam. If the automated test fails, the build is not pushed. Well, if we had a more advanced AI, we could have done gameplay analysis of our levels to determine whether there were too many moments without action, if there was too much action in some spots, and to give suggestions where the level design could be improved to make gameplay pacing more consistent. This could have been accomplished by having AI play the game over and over and keep track of all the gameplay. Incredibly powerful AI would have been able to directly edit the level files and make level editing changes to fix the gameplay pacing. Then it would have used automated testing to ensure that its changes were correct. I can only imagine how amazing it's going to be when we can actually use AI like that in game development. For Doom, we could have used AI to clean up the scanned video files like this one of the models that we created for monsters or the ones that we used for guns. Advanced AI could have generated the pixel art animations of all the characters in the game. AI could have arrived at the BSP solution that we use for drawing levels at high speed. That's binary space partition. Or maybe AI could have suggested an even better algorithm. AI definitely could have sped up the creative process of choosing level location ideas, narrative ideas, character names, and many other things. Instead of creating Doom in 11 months, we could have done it faster. By the time Quake development would have started, we would have been pretty great at using AI. We would have possibly gotten the suggestion to split the game into 2 different games, highlighting a few technology innovations in each one, instead of making one game with a bunch of innovations in it like we did. We could have used AI to help write the perspective correct texture mapping assembly language code. We could have used it to help write the 3D level editor. More advanced AI would have been able to develop the model texturing tools and code faster. So some of these things were already innovative, but AI could have been used to help push forward each step in the development of these innovations a little faster. I think that's where AI really shines, as an expert sidekick that can help you look at problems, generate ideas, and analyze information. Using AI this way as you do your job really supercharges your abilities. As AI models race ahead into the future, we are following them, and we're getting better at using AI as an incredible tool. Learning skills that complement AI is the way to making products better. I'm sure that's a key factor in Atera's success. Thank you. Thanks for joining me today and hearing all about my journey. I invite you to stick around because Atera has more great content for you right after this. Now I'd like to pass the mic to Gil and Lee as they discuss the challenges we're all facing and how AI is changing our future. Enjoy!